Hello. Today we're going to talk about 11.7 standard deviation. So, standard deviation is how far away your values deviate from the norm, okay, from the mean. Okay? So, this is it mathematically. Okay? So, if you want to go, the engineer route and you want to do things by hand, yeah, it helps to know this by hand, but typically our calculators do it all for us. So I'm going to show you how to do that. So here we have our first example. So to do it mathematically, right, or algebraically, I guess I should say, you start by finding the average. So the average is 7.4. Then you take every value and you subtract the mean. So 6.9, 8.7, you take every value, subtract the mean. You take that difference and you square the difference. And then we take those new decimals, those new values, and we average those. Okay, so the average of those is your variance, right? Sigma squared is variance. It's like a circle with a line on top. Then if you take the square root of it, that's your standard deviation. Okay, so that's how you can get it. You can also get it by using your calculator. So you get out your calculator, you do stat edit, you put in your data set, then we're going to do stat calc, one variable stats, list one, and here we have our mean, which was 7.4, and our standard deviation, the sigma x, is 1.50. Now, if you want to get the variance, you just take that value and square it. Do not type in 1.5 and square it. All right, you want to get as close to that as possible, so I would do a whole bunch of those decimals. Write them all down, square the whole thing, and then round your variance. Okay? Now, what does that mean? Well, we can graph this. Here, let me move this over a little. Okay, so let's show it like based on the normal curve. Okay, if this was normal, then we would say the mean is 7.4 and the standard deviation, usually we go 3 standard deviations. Okay, so we go up 1.5 and down 1.5. So if we go up, we get 8.9, then we get 10.4, then 11.9. Then if we subtract 1.9, we get 1.5. Then we get 4.4, and then 0.9, 2.9. Okay, so most of my data, according to the normal curve, should fall between 2.9 and 11.9. Which it does. Okay, so this is a visual representation of. All right, so let's do number 2. So if we plug this into our calculator, we would get the mean is 69.8. The variance is 115.14, and the standard deviation is 10.73. So to show your work, you can do a normal curve, show your mean in the middle, and then do your 3 standard deviations. Okay, oh, hopefully you draw that a little bit more proportion than I do. All right, so then we have 69.8. We're going to add the standard deviation. So we get 80.53 plus another 1073. And another. All right, so then we take the difference and we start subtracting it. We get 59.07, then 48.34, and 37.61. So all of our data usually falls within 3 standard deviations. And notice all of our data set did. Obviously, we have a very small amount So it's not very likely that you'll have something way out in the extremes. All right, so why don't you try these two examples on your own, see what you get. So pause it. All right, the answers are, all right, so hopefully this is what you got. And if it's not, let me know in class. We'll see what's going on. If you don't have a graphing calculator, you got to do it by hand. Okay, so I won't give you anything with crazy amount of data, but it helps to have a graphing calculator. All right, see you in class.